All right, we'll go ahead and start with problem number 1. Well, you're given the quadratic function f of x is equal to x squared minus 2x minus 3. And you're going to perform the following. So here you're just going to have these 5 things you're required to do. Determine whether the graph opens upward or downward. And then identify the vertex of the parabola. Then find the x-intercepts and then find the y-intercept. And then in part E, you're to sketch the graph using the intercepts, vertex, and sometimes some additional points that you might need in order to graph that parabola. Okay, so all right, so problem number 1, we got the function f of x is equal to x squared minus 2x minus 3. So here we want to determine whether the parabola opens upward or downward, which is part A. And to do that, we always look at the coefficient of your x squared term. If it's positive, it opens upward, or if it's negative, it opens downward. So in this case here, A, which is the coefficient of x squared, that's going to be 1. And it is positive, so that means that the parabola, the graph of this parabola, opens upward. The graph of this parabola opens upward. So that's part A. And in part B, we want to find the vertex of this parabola. And also, I'm going to include with that the axis of symmetry. So here, to find the vertex and the axis of symmetry, we need to identify 2 things, the A and the B. Your A is the coefficient of x squared, and the B is the coefficient of x. So the coefficient of your x squared term is 1. What's the coefficient of B? Negative 2. And then we use x equal negative b over 2a. We use x equal negative b over 2a. So here we just substitute, bring the negative over, replace the b with negative 2, so it'll be negative of negative 2 divided by 2 times a, which is 1. And then negative of negative 2 is 2, over 2 times 1, which is 2. And then 2 divided by 2. That'd be 1. So x, the coefficient, well, the x-coordinate of your vertex will be 1. Now to find the y-coordinate of the vertex, we just take x equals 1, substituted for the x in our f of x function. So we evaluate f of 1 by just replacing each x in that function with 1. So I have 1 squared minus 2 times 1 minus 3. And then we simplify. Square the 1, that's going to be 1, minus 2 times 1, which will be 2, then minus 3. All right, so what's 1 minus 2 minus 3 going to be equal to? Negative 4. So the vertex of this parabola will be the ordered pair 1, negative 4. Now for the axis of symmetry, the axis of symmetry is just going to be the x-coordinate of that vertex. Where here x was equal to 1, so that means that x equals 1 will be your axis of symmetry. Any questions on part B? Now for part C, it's finding the x-intercepts. Now, of course, the x-intercepts are going to be the points where this parabola will be crossing the x-axis. And to find the x-intercepts, you always take the function f of x, set that equal to 0. And here f of x is at x squared minus 2x minus 3. And then we set that equal to 0. Okay. So for the x squared minus 2x minus 3, we need to factor that into two binomials here, since it's a quadratic equation. Okay, so here the x squared breaks up as x and x. And then the factors of negative 3 that will give me minus 2x as a middle term will have to be 3 and 1. And of course, the larger of the two factors will take the sign of the middle term. Since the middle term is a minus, that means the 3 has to be minus and the 1 has to be plus. So the x minus 3 times x plus 1 equal to 0. And then we set each binomial factor equal to 0 and solve. So that means I have x minus 3 is equal to 0, or x plus 1 is equal to 0. And then we solve each equation for x. So for the x plus 3 equal to 0, x is equal to 3. Then for x plus 1 equals 0, if I subtract 1, that means x is equal to negative 1. So that means my two x-intercepts are going to be 3, 0, and negative 1, 0. Those will be the points where this graph will be crossing the x-axis. I mean, where the graph of the parabola crosses the x-axis. Okay, and then part D is to find the y-intercept. So to find the y-intercept, you always let x equal 0. Okay. So when I substitute 0 in for x, this will be 0 squared minus 2 times 0 minus 3. Okay. So 0 squared is 0, minus 2 times 0 is 0, minus 3. That's going to end up being negative 3. So the y-intercept will be the ordered pair 0, negative 3. And then part E is just doing the graph, using your x-intercepts and your y-intercept, the vertex, and possibly additional points. Okay. And by the way, on the exam, you will have graph paper to graph your parabola. So already we know that the parabola opens upward, and the vertex is 1, negative 4, so I'm going to go to the right 1 and down 4. And also I'm going to draw in the axis of symmetry, which is, in this case, x is equal to 1. And that axis of symmetry is that vertical dotted line. So that vertical dotted line going through the vertex and the x-axis. Also, my x-intercepts are 3, 0, and negative 1, 0. Okay, so 3 zeros on the x-axis and negative 1 zeros on the x-axis. My y-intercept is 0, negative 3, so I stay at 0, go down 3. That point will be on the y-axis. Now, for the additional point, it's going to be this. If I look at the distance from that y-intercept to this axis of symmetry that I drew, that distance is one place to the left. So the other point with the same y-coordinate will be one place to the right. Because symmetry means this. The left side has to be the mirror image of the right side. So that point would be right here. And then from that, I'll go ahead and draw the graph of that parabola. So that's the graph of f of x equal to x squared minus 2x minus 3. Are there any questions about problem number 1? Okay. All right, now problem number 2 is this. You're given the quadratic function. Quadratic function is f of x is equal to negative 4x squared plus 160x minus 600. All right, and there are 3 parts to that problem. In part A, you're to determine without graphing whether the function has a maximum or minimum value, and then find the minimum or maximum value and determine where it occurs, and then identify the function's domain and range. So in this case here, part A is finding out whether we have a maximum or a minimum value by looking at the coefficient of our x squared term. Okay. If it's positive, that tells us we have a minimum value, or if it's negative, we have a maximum value. So what is the coefficient of x squared? Negative. Do we have a maximum or a minimum? Here we have a maximum value because our a is less than 0, or we can say that it is negative. So part A is just all we have to do there. In this case, we have a maximum value. Now in part B, we're going to find out what that maximum value is and where it occurs. So this is part B. We know what A is, that's negative 4. What's B? 60. That's the coefficient of your x term. And then we use x equal negative b over 2a to determine where that maximum value occurs. So just substituting here, we're going to have, let's see, negative of b, which is 160, over 2 times a, which is negative 4. So here I'm going to have negative 160 over 2 times negative 4, that's negative 8. What's negative 160 divided by negative 8? 320. So we know the maximum value occurs when x is equal to 20. So now let's go ahead and find out what that maximum value is going to be. So we're going to substitute 20 in for x in our f of x function. So f of 20 will be this. Negative 4 times x, which is 20, and that's squared, plus 160 times x, which is 20, minus 600. And if you simplify this, 20 squared is 400. Then 400 times the negative 4 would be negative 1,600. 160 times 20 would be 3,200. And then minus 600. and then negative 1600 plus 3200, that will be 1600, minus 600 would be 1000. So that 1000 represents the maximum value, and it occurs when x is equal to 20. Okay. And now part C is identifying the function's domain and range. Now the domain is easy to identify because it is a quadratic function, which is simply a polynomial function. And in a polynomial function, any x value that you assign to it, you're always going to get an f of x value for it. So there are no restrictions on a quadratic function. So the domain would be from negative infinity to infinity. And you're going to ask to be given to provide the domain using interval notation. Also, the range will be in interval notation as well. So the range is this. Since we have a maximum value, that means that this 1000 right here will be the highest y value that the graph of this function will ever reach. So in interval notation, the range will have to be from negative infinity up to 1000. With the maximum value, that range would be from negative infinity up to whatever that maximum value is. But if it was a minimum value, then it would be that minimum value itself up to infinity. Okay? Any questions about problem number 2? All right, problem number 3 deals with the leading coefficient test, and that's from section 3.2. Here you're going to be using that leading coefficient test to determine the end behavior of each polynomial function. And in part A, you got f of x equal x to the 5th plus 17x cubed minus 11. And here we want to use that leading coefficient test. And might want to refer to the notes from section 3.2, because I did provide that leading coefficient test there. So you might want to include that whole thing in your one-page sheet of notes. In this case here, we identify the n and a sub n. That n, of course, is the highest exponent of that entire function. So in this case, what's your highest exponent? It would be 5. And the a sub n is the coefficient of the variable to the highest exponent. We call that the leading coefficient. And what would that be? 1. Okay? So in this case here, n is 5. If n is odd, then we look at our leading coefficient to determine whether it's positive or negative. Or if n is even, then we look at the leading coefficient to determine whether it's positive or negative. Here, n is odd, and your a sub n is positive. Okay? Now, according to the leading coefficient test, n is odd and a sub n is positive. That means that the behavior of the graph of f of x would be this. It's going to fall to the left, and rises to the right.
Can we do arrows?
Yeah. Falls to the left and rise to the right. And I know that the end behavior has to be in opposite directions because our highest exponent was an odd number. If it was even, then it'll have the same behavior on the left and on the right. Questions on part A. All right, now part B, we got f of x is equal to negative x to the 6 plus 7x cubed plus 2x squared minus 8x minus 12. And I want to find the end behavior of the graph of this function. All right, so now what's our n in this case? 6. And what's a sub n? -1. That's the negative sign in front. All right, so here n is even, but what about a sub n? Negative. So the behavior of that would be that f of x, and since it's negative, it's going to have to, no, n is even. They're going to have the end behavior on the left, it'll be the same. And since it's negative, that means it's going to fall to the left and to the right. All right. Are there any questions about problem number 3? All right, and problem number 4 is finding the zeros of the polynomial function. And in this case here, we're dealing with f of x is equal to 3 times the quantity x minus 2, and that's squared, times x plus 5. And that quantity is cubed. And give the give the multiplicity for each zero, and then state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Okay. So in this case here, to find our zeros, we just set f of x equal to 0. And that would mean I'll have this 3 times the quantity x minus 2, and that's squared, times x plus 5, quantity cubed, equal to 0. Now, it's already factored completely, so all we're going to do there is just set each factor equal to 0 and solve for x. So in this case here, I'll set 3 equal to 0, and then set x minus 2 quantity squared equal to 0, and then set x plus 5 quantity cubed equal to 0. And in this case here, 3 equals to 0, I can scratch that out because that is a false statement. And then for the x minus 2 quantity squared equal to 0, if I solve for x, the opposite of squaring something would be to take the square root on both sides. So that will give me x minus 2 equal to 0. Add 2. That will mean x is equal to 2. And then for the x plus 5 quantity cube equal to 0, the opposite of cubing something would be to take the cube root on both sides. And then the cube root of x plus 5 quantity cube will be just x plus 5 equals to the cube root of 0, 0. Then subtract 5 on both sides. That will mean x is equal to negative 5. So these are my zeros of this polynomial function. X equals 2 and x equal negative 5. Now I need to state the multiplicities for each of these zeros. Let's start with the x is equal to 2. All right, so for x equal 2, that came from the x minus 2. That exponent will tell you what the multiplicity is for that 0. So the exponent for the x minus 2 was 2. So x equals 2 has a multiplicity of 2. And the other one for x equal negative 5, that came from x plus 5. The exponent for that would be 3. So x equal negative 5 has a multiplicity of 3. And now we want to find out what the behavior is at each of those zeros. Now, if your 0 has an even multiplicity, that means your graph is going to touch the x-axis and turns around. Or if you have a 0 with an odd multiplicity, what's going to happen is that the graph of the function will cross the x-axis at that x value. So for x equals 2, with that multiplicity of 2, the behavior will be this. Since it's an even, it's going to touch and turn. Touches the x-axis at 2, and it's going to turn. Now for the x equal negative 5 with that multiplicity of 3, what will be the behavior there? It's odd multiplicity, so it means it's going to cross the x-axis. Are there any questions about problem number 4? All right, number 5 is a graph of a rational function. Here we got f of x is equal to 4x squared divided by x squared minus 9. And here we're going to follow the 7 steps to graph the rational function. So this is back in section 3.5. So the first step is to determine whether or not I have symmetry. And if I do have symmetry, what type of symmetry? It could be origin symmetry, or it could be y-axis symmetry. And to find that out, I have to replace each x in this function with negative x. So I'm going to evaluate f of negative x. And that's equal to 4 times negative x and s squared divided by negative x and s squared again minus 9. So in this case here, if I simplify this, if you square a negative, it's going to be positive, so that numerator will be just 4x squared over, again, negative x, you square that, that'll be x squared, and then minus 9. So now compare that with my original function. Here I got the original function that I started off with after replacing the x with negative x. So that means here, this graph is symmetric with respect to the y-axis. Now, for it to be symmetric with respect to the origin, when I replace the x with negative x, I should get the opposite of the original function that I started off with. So that's part A. All right, step number 2 is going to be finding the y-intercept. So to find the y-intercept, we substitute each x in the f of x function with 0. So we're going to evaluate f of 0. That would be 4 times 0 squared divided by 0 squared minus 9. So in this case here, if I square the 0, that's 0 times the 4 in front, that would be 0. Divided by 0 squared is 0 minus 9 would be negative 9. So 0 over negative 9 ends up being 0. So my y-intercept would be the ordered pair 0, 0. That's step number 2. Step number 3 is finding the x-intercept. Now to find the x-intercept, you take your numerator, which is 4x squared, and set that equal to 0. So I'm going to take that 4x squared and set that equal to 0 and solve for x. So in this case here, if I divide both sides by 4, that would mean x squared equals 0. And of course, if I take the square root on both sides, that would mean x is equal to 0. So that means the ordered pair 0, 0 is also the x-intercept. Okay. All right, I'm going to do step number 4 over here on this side. All right, in step number 4, you're going to find the vertical asymptotes. That's going to be those two vertical dotted lines going through the x-axis. And to do that, you have to set your denominator, x squared minus 9, to be equal to 0. And of course, you want to make sure that your f of x function has no common factors in it, and it does not. So I can set x squared minus 9 equal to 0 and solve for x by adding 9 to both sides. That would mean x squared is equal to 9. And then if I take the square root on both sides, I must include that plus or minus symbol. So that means x is equal to plus or minus 3. Which means here my two vertical asymptotes are x is equal to 3 and x is equal to negative 3. Those are my two vertical asymptotes. All right, number 5 is finding the horizontal asymptotes. All right, so to find the horizontal asymptotes, we have to identify two things, the n and the m. Your n is the highest exponent in the numerator, your m is the highest exponent in the denominator. So I'm going to bring this down a bit. What's the highest exponent in the numerator? 2. And what's the highest exponent in the denominator? Also 2. So n and m are equal to each other. So that means that the y, my horizontal asymptote, I have to use my leading coefficients in the numerator and in the denominator. What would be the leading coefficient in the numerator? 4. What's the leading coefficient in your denominator?
1.
So 4 divided by 1 will be 1. That means the equation y equal 4. Y equals 4. That would be the horizontal asymptote. That's going to be the horizontal dotted line going through the y-axis at 4 in this case. Okay. And I'm going to do 6 and 7 down here. Because in number 6 is going to be the table of values. And then number 7 is just a graph of the function. All right, so let's go ahead and graph what we already have in this case. We already have the Y-intercept and the X-intercept. They're both at the origin 0, 0. I have my two vertical asymptotes, which are x equal 3 and x equal negative 3. So I'll go ahead and draw those in. So these are my vertical asymptotes. The horizontal asymptote was y is equal to 4. So I'll go ahead and draw that in as well. Now, we're going to pick values of x on the left and on the right of each vertical asymptote and the x-intercept. And we're going to use our graphing calculator to help us out with this. So, my first vertical asymptote is at x equal negative 3. I'm going to pick x values like x equal negative 6, negative 5, negative 4. And to the right of x equal negative 3, I'm going to pick negative 2 and negative 1 as x values. My x-intercept is at 0, so let's use x equals 1 and x equals 2. The other vertical asymptote is at x equals 3. I'm going to use x equal 4, 5, and 6. All right. So now we're going to use our graphing calculator for this. So here, let me clear this out. I'm going to go to y equal 2, and I'm going to clear all this junk that I got in this calculator that I was using over spring break. And plot 1, 2, and 3 should be off. And then I'm going to enter the equation as is. So, and I'm going to do the numerator. I'm going to put the equation, the numerator and the denominator in parentheses. So it would be something like this. Left parentheses, type in the 4. To get the x, you have to press xt theta n for that. And then hit the X squared button to square it. All right, so left parentheses, 4 xt theta for your x, and then square it, close parentheses. And then that's going to be divided by, the denominator will be in parentheses as well, so it'll be left parentheses. For the x, you're going to press xt theta in, and then the x squared button to square it, press the minus button, and then number 9, close parentheses. All right. Now for the table, you're going to press second and then graph. So I'm going to press second and graph for the table. Okay. I need to fix something here. Okay. There we go. And sometimes you may have to use your up arrow or your down arrow key to get to the x values that you want. Like in this case here, I need to use my up arrow key to get to x equals 6, negative 6. So for x equals negative 6, I'm going to round to one decimal place. So this will be 5.3. And then for the x equals negative 5, and then for negative 4 will be 9.1. Now, as x equals negative 3, you see the arrow, that's one of your vertical asymptotes. At negative 2, okay, and for negative 1, and of course 0, 0 is your x and your y-intercepts. So if you use your down arrow key to get to the x values that you want, for 1, that's what, negative 0.5? And then for x equals 2, that will be negative 3. So you can see at negative 1 and positive 1, you're going to get the same f of x values. For negative 2 and positive 2, the same f of x values. So for 4, 9.1, for 5, 6.3, and for 6, 5.3. Okay, so now these are the points I'm going to use to graph this rational function. So for negative 6 and 5.3, we'll go to the left 6 and up 5 and about 1/3 of the way, which would be about right here. And then negative 5 and 6.3, this would be about right here. And then negative 4 and 9.1, that's a little bit past 9. So I know what the behavior at one end of the graph would be. It's going to come up this way, approaching the horizontal asymptote of x equals negative 3, but it will never cross it. The other end will be approaching the horizontal asymptote, but it will never cross it as well. Okay. All right, so negative 2 to negative 3.2 will be to the left 2 and down 3 and about 2/10 of the way, about right here. Negative 1 and negative 0.5, or negative 1/2, will be about right here. And then 1 and negative 0.5 will have the same y coordinate. 2 and negative 3.2, the same thing. So between negative 3 and positive 3, which are my vertical asymptotes, on the left side it's going to come down, approaching the first vertical asymptote, but it will never cross it. The other end, to the right of 0, comes down, approaching the second vertical asymptote, but will never cross it. So you can see here the left side has the mirror image of the right side. And then these last 3 points will have the mirror image of the ones that are on the left. So for 4 and 9.1, that's going to be up here. 5 and 6.3, and then 6 and 5.3. So here's going to come up approaching the vertical asymptote of x equal 3. It's going to come down going this way, approaching the horizontal asymptote at y equal 4, but I'll never cross it. So that is what the graph of f of x is equal to 4x squared divided by x squared minus 9 will look like. Okay. Are there any questions about problem number 5? Just graphing a rational function. Okay. Problem number 6 through 13 are going to be from sections 4.1 and 4.2. This one is an exponential function in number 6. And you're going to approximate each number using a calculator, rounding your answers to 3 decimal places. So in part A of number 6, we have 3 raised to the 2.4 power. So let me do second and mode to quit. To enter that, you're going to type in the number 3, and then press your hash key, and then 2.4. And then press enter. So the 3 decimal places, what would this answer be? 13. Right, 13.967. And then in part B, we got e raised to the 3.4 power. Now for the e, of course, we're going to press second and then your LN button for e to the x. Second LN, and then type in 3.4. 3.4, not 2.4.
Oh.
Twenty-nine 29.964, yeah. All right, any questions about problem number 6? Okay. All right, number 7. We're going to find the accumulated value of an investment of $10,000 for 5 years at an annual interest rate of 8% if the money is A, compounded quarterly, and then B, compounded continuously. So let's take a look at what we got. We have a $10,000 investment, so that's what P is, $10,000 for 5 years. That means T is going to be 5, because T is the time in years. Annual interest rate, that's going to be R, which is, in this case, 8%. Well, what's 8% as a decimal? 0.08. Drop the percent sign, move the decimal point 2 places to the right, or you can take that 8 and divide that by 100. That'll give you the decimal form of the interest rate. So now in part A, they want the accumulated value if it was compounded quarterly. That means how many compoundings are there in a single year? 4. So n would be equal to 4. And with n number of compoundings, we have to use this formula. A is equal to P times the quantity, 1 plus R, divided by n, and that's raised to the n times t. And then we just substitute those values into this compound interest formula to find out what A is. So A is going to be, your P is 10,000 times the quantity 1 plus R, that's 0.08, divided by N, which is 4, and that's raised to the N times T. So N is 4 times T, which is 5. Now all of this can be typed into the graphing calculator. So we type in 10,000, then left parentheses 1 plus 0.08 divided by 4, close parentheses, and then for the exponent, press your hat key, 4 times 5. And then close the hit enter. Now we're dealing with money amounts, so we have to round to 2 decimal places. So what would this amount be to 2 decimal places? Yeah, 47. $14,859.47. All right. So that would be the accumulated value of a $10,000 investment for 5 years at 8% compounded quarterly. And then part B is compounded continuously. And here we have to use the formula for continuous compounding. That's the one with the natural base E in it. A is equal to P times E to the RT. And then we just substitute the P with 10,000 times E to the R, that's 0.08, times T, which is 5. So in this case here, we'll type in 10,000. And then for the E, of course, second, LN for your E, then 0.08 times 5. And then hit enter. And to 2 decimal places, what would this amount be? And 25. Because the second digit after the decimal point is a 4 to the right of it is 6. Rounds up to 5. So it'll be $14,918.25. Okay. Questions about problem number 7? All right, number 8 is to write the equation log to the base 6 of 216 equals to y in its equivalent exponential form. So here we're going to write this logarithmic equation in its equivalent exponential form. So in this case here, we need to use that study tip that I gave you back in section 4.2. Starting with the subscript for your logarithm, that's going to be the base. What's after the equal sign will be the exponent for the 6. So it'll be 6 to the y equaling to what you're taking the log of. So it'll be 6 to the y equaling to 216. And that's all there is to it. So log to the base 6 of 216 equaling to y would be 6 to the power of y equaling to 216. and that's in its equivalent exponential form. All right, questions on number 8. All right, number 9 is in exponential form. You have 7 to the power of y equaling to 200. And we're going to write in its equivalent logarithmic form. Log to the base 7 of 200 equals to y. Okay, and that's all there is to it. Because you have to have log in it for the log, because it's got to be in logarithmic form. Your 7 is your base. That's going to be the subscript for your log. That 200 will be after the logarithm, equaling to the exponent of y. Questions on number 9. All right, number 10 on the next page. Is to evaluate the expression log to the base 2 of 64. So in other words, we're trying to find the missing exponent here. Anytime you're taking the log of something, you're finding the missing exponent. And I'm going to let y be that missing exponent that I'm trying to find here. And if I convert that into its equivalent exponential form, it's going to be this: 2 to the y, which is that missing exponent, equals 64. So in other words, 2 to what power would be equal to 64? Well, since this base is 2, let's do this. I'm going to keep dividing by 2 to see if I can write 64 with a base of 2. So 2 goes into 64 32 times. Then I'll divide 2 again. 2 goes into 32 16 times. Divide 2 again. 2 into 16 goes 8 times. Divide 2 again. 2 goes into 8 4 times. And then divide 2 again. 2 goes into 4 2 times. And of course, 2 goes into itself 1 times. So how many times 2 is used as a factor? 6 times. So that means 64 with a base of 2 will be 2 to the 6. Now, there's a rule that says here, if my bases are the same, I can set this exponent to be equal to that exponent. Since these 2's are the same, I can set the y to be equal to 6. And that would be the missing exponent that I was trying to find. So in this case here, to the base 2 of 64 is equal to 6. Log to the base 2 of 64 is equal to 6. Are there any questions about problem number 10? So I'll go ahead and box this in. All right, number 11 is to evaluate or simplify each expression without the use of a calculator. And that's pretty much using those basic properties of logarithms. So in this case here, number 11, we got the log of 10 to the 7th power. Now, of course, there is a property that does state that if you have the log of 10 to whatever your exponent is, it's going to be that exponent. That's one of those inverse properties. Okay. So in this case here, if I apply that property, what would log of 10 to the 7th be? 7. Of course, log to the base 10 and base 10 itself are inverses of each other. Questions about problem number 11? All right, number 12 is ln of e to the 9. That's one of those inverse properties for natural logarithms. If you have ln of e to whatever your exponent is, it's going to be that exponent. So what would ln of e to the 9 be? 9. Questions about problem number 12. And then number 13, you got e to the ln of 7x cubed. And this follows the other property for inverse logarithms. E to the ln of whatever you have here is going to be whatever. So what would e to the ln of 7x cubed be? Just 7x cubed. Are there any questions about problem number 13? Or does anybody have any questions about what will be on Thursday's exam covering this study sheet?